got questions you need to fill out, or here's some helpful stuff. DC and EF are exactly the same, parallel to each other, which makes life easy. They're actually the same size, same distance, and same angle, so we don't have to worry about that. AB and GH are perpendicular to one another, which makes life easy. You can figure that out in a second here. And AB and KJ are parallel, okay? Up here. Again, is helpful information. What you have is on the blackboard is this, I think. All right, let's just get rid of a bunch of this stuff. And what you end up doing is having to create the road in there. Now, once you get that done, all right, a couple things here. I think if your road hits a tree, you probably did it wrong, except for this one here. The file that I gave you, this one might just barely cross it, okay? Units. Shouldn't have to change them, but if you do, there you go. All we need is, actually, we need surveying units, okay? And 1 is enough. All we're doing is degrees here because this says south 4 degrees east. We do a line. AB is 300 units long. Stretching crazy. My object snaps were happy here. Quadrant perpendicular. All right. So we start off here. We say at 300 less than south 4D E and enter. And there's your line you're starting with. Okay? Once you get that one done, a couple things about the problem. Moving on down here as we can see it. Okay? There are certain things about geometry you should know. Alright? A tangency point is a big key to creating this problem. What happens is when you have a line coming from the center of the arc to that tangency point, that line will be perpendicular to the other line. Alright? In other words, from the radius there on the end, the center point, which is between C and B, if I go out to point B, the line there will be perpendicular to A and B. It is a known fact. Alright? It's always perpendicular. So using that knowledge helps you create this file. Alright, the drawing. So, how do I do that in AutoCAD? Well, one of the easiest ways that I know, anytime I need a perpendicular distance, I use offset because it takes that exact object a perpendicular distance away, right? So, if I use offset here, I got a 75 radius, so I can type in 75 for my perpendicular distance, and I can click on this and hit this. And then I can just draw a circle from that endpoint out to the endpoint of there. And I know it's going to be accurate. Okay? Plain and simple. The next thing, 10 degrees. Alright? This is where you do a little bit of math. If I'm already coming south 4 degrees off of north in this case, 10 more degrees means I'm at 14 degrees, right? Which makes sense. So I'm going to go 14 degrees off of this toward the west. Well, my length here is 150. You will not be able to get this point any other way other than using tangency. Okay? And with tangency in AutoCAD, it gives you the automatic tangency point without you having to figure it out. Which makes your life much easier. Line, tangent to the circle. You'll notice as I'm moving, it's moving the tangency point. So in this case, I'm doing add 150, less than, north, 14D toward the west, and enter. There's my line component. Okay? Nice part about it is, EF is actually parallel to the same distance as CD. Offset it, 150. Makes life a lot easier. There we go. I can do a circle using 2 points. end point of that line to the end point of that line gives me the top guy, right? And then, even better, is when I get down to this point, F and G are concentric circles now. So I can use this center point back up here to create this arc down here. Again, there it is. Circle, here, out to here, gives me the bottom guy, all right? Now, it said AB and GH are perpendicular, right? So if I'm 4 degrees off of due north, that means I got to be 4 degrees off of east-west, right? Makes life easy. So 4 minus 90, 86 degrees, right? In this case, we could do north 86D to the east. And that'll figure out our tangency point here, which line tangent to here at whatever the length it is, 270, less than north 86D to the east. And there is your point GA. Okay? Same concept. At the end here, we've got a big radius to do, 150, perpendicular to it. So all I got to do is offset it, 150, and draw my big circle. At this point, you're at a standstill, at least going in this direction. Because if you pay attention, there's no radius or IJ, okay? I had to search long and hard to figure out how to come up with this, but there is a way to use it using descriptive geometry. First thing you got to do is draw K and J here, because I know the length of it and I know the distance from it. So as I could do this, coming over here, 150 units. All right, I'm going to draw a line real quick, perpendicular, and then I'm going to move it from there to K. Why do I do this? So that I can actually trim off that line. I could have went over, then I could draw another line at 100 units south, 4 degrees east, and I can do the same line. Or I can use this, and I can offset this down 100 units and get J. Trim it up real quick. Get rid of it. Don't need the top one, do need the bottom one. All right? Point of tangency, line goes through the center. So I know somewhere along this line perpendicular at J, a center point is going to be created. All right? It's a known fact. All right? Also, from the center of this one out somewhere through this, these two will cross and that will give me the center point. There's a point of tangency here at I. So how do I end up getting that? Okay? This is sort of the trick behind the whole thing. We're going to draw a line and we're going to call it tangent over here. Okay? When you have a line parallel with an existing line, okay, on the opposite end of the circle, right? You connect, once you find the tangency point to it, connect the endpoints, and that diagonal line will cross through the intersection of the two arcs. Okay? So, all you really need here is just to draw an arbitrary line of arbitrary length at a very specific angle, south 4 degrees east, and we'll have it done. So let's say at 222, don't care, less than south 4D east. Okay? Make it parallel. I don't really care. All I really care about is this endpoint. All right? This intersection. Right there. I'm going to draw it to point J here. Now, along this line where it crosses the arc is the intersection of the tangency point between the two arcs. Okay? From that, I can draw a line from the center through this intersection and extend both of these guys using fillet with a radius of 0 here and here. There is the center. I draw a circle. Draw a circle. There we go. Here to here. and you'll notice it goes through your intersecting point there, without even knowing the radius. Okay? Once you get this done, trim everything up, you offset it, P-edit. Okay? P-edit actually joins things together. We'll show you real quick. Let's trim a few things here off so that I can show you the P-edit. Okay? P-edit, typing it in. It says, hey, this is not a polyline. Do you want to make it one? We say yes, and then we hit join. Click on all the things you want to join to it. And then when you do that and you offset, what was our road distance? 30 total. Okay? So we'll say 15. Click on this, inward, outward, change that to a different center line layer, and you're going to have your whole road created sort of instantly. Okay?